When dealing with a fire pump installation that includes feeds from two sources, such as a utility feed and an on-site generator, the question arises of how to properly size the overcurrent protection for the feed coming from the generator. A commentary note in the National Electrical Code Handbook indicates that this overcurrent protection should be sized like a normal motor feeder, not just for short circuits like the utility feeder. The commentary note can be found in section 430.22c, exception no. 2 of the National Electrical Code Handbook. This exception states that the overcurrent protection for a motor circuit supplying a fire pump motor shall not be required to have a rating greater than that for a motor circuit supplying a similar motor not used for fire pump purposes. The National Electrical Code does not explicitly state that the overcurrent protection for the generator feed to a fire pump should be sized like a normal motor feeder. However, the commentary note suggests that this is the intended interpretation. The requirements for the overcurrent protection of a motor circuit are found in Article 430 Part Roman 3 of the National Electrical Code. Section 430.52b states that the overcurrent protection must meet specific criteria. Firstly, it should not be greater than the maximum branch circuit rating for the motor. Secondly, it should not be greater than the motor nameplate current unless the motor controller is rated for continuous duty at 125% of the motor nameplate current. For a fire pump motor, the maximum branch circuit rating is not explicitly specified. However, the motor nameplate current is typically 125% of the full load current. Therefore, the overcurrent protection for the generator feed to a fire pump can be sized to 125% of the motor nameplate current. The rationale behind the commentary note and the National Electrical Code requirement is that the generator feed to a fire pump is not a typical motor feeder. Fire pump motors are primarily used in emergency situations, and therefore, the overcurrent protection does not need to be sized for continuous duty. Additionally, fire pump motors are typically sized for 125% of the full load current, allowing the overcurrent protection to be sized accordingly. To elaborate on Article 430 and its implications for fire pump motor circuits supplied by generators, it's essential to delve deeper into the specific sections and their practical applications. Article 430 covers motors, motor circuits, and controllers, providing comprehensive guidelines for ensuring the safe and reliable operation of these systems. When dealing with fire pump motors, understanding the nuances of overcurrent protection is critical due to their vital role in emergency situations. Section 430.22c, exception no. 2, as highlighted in the National Electrical Code Handbook, offers a significant allowance for fire pump motor circuits. It suggests that the overcurrent protection for these motors does not need to be rated higher than that required for a similar motor used in non-fire pump applications. This exception acknowledges the unique operational characteristics of fire pump motors, which are primarily used during emergencies and are not subjected to continuous duty like many other motor applications. The reference to Article 430, Part Roman 3, specifically Section 430.52b, further clarifies the requirements for overcurrent protection. This section stipulates that the overcurrent protection must not exceed the motor's maximum branch circuit rating or the motor nameplate current, unless the motor controller is rated for continuous duty at 125% of the motor nameplate current. For fire pump motors, the absence of a specified maximum branch circuit rating necessitates a focus on the motor nameplate current. Since fire pump motors are commonly sized at 125% of the full load current, the overcurrent protection for the generator feed can be set at this value. It's important to understand the rationale behind this approach. Fire pump motors are designed to operate under emergency conditions where reliability is paramount. Sizing the overcurrent protection at 125% of the motor nameplate current allows for the motor to deliver its rated output without nuisance tripping during critical fire suppression operations. This sizing approach also accounts for the motor's ability to handle temporary overloads that may occur during these emergency situations. To ensure compliance with the National Electrical Code and maintain the integrity of the fire pump system, it is essential to perform a thorough analysis of the motor's characteristics and the specific requirements of the installation. This analysis should include a review of the motor nameplate data, the motor controller's capabilities, and the overall system design. In addition to the overcurrent protection, other aspects of the generator feed to the fire pump must be carefully considered. These include the sizing of the conductors, the selection of appropriate disconnecting means, and the coordination of protective devices to ensure selective tripping. Selective tripping is crucial in emergency systems to isolate faults without disrupting the operation of other critical equipment. The conductors supplying the fire pump motor must be sized to carry the motor's full load current, with appropriate adjustments for voltage drop and ambient temperature. The disconnecting means must be readily accessible and clearly labeled for emergency use. Furthermore, the generator itself must be capable of providing the necessary power and voltage regulation to support the fire pump motor under all operating conditions. Regular testing and maintenance of the fire pump system are essential to ensure its readiness and reliability. This includes periodic testing of the generator, the motor, the pump, and all associated control and protective devices. Any deficiencies identified during testing should be promptly addressed to prevent failures during actual emergencies. The National Fire Protection Association, or NFPA, also provides standards and guidelines for the installation, testing, and maintenance of fire pump systems. NFPA 20, Standard for the Installation of Stationary Fire Pumps, offers comprehensive requirements for ensuring the proper operation of fire pumps and their associated equipment. Adherence to NFPA 20, in conjunction with the National Electrical Code, is crucial for maintaining a safe and reliable fire protection system. In summary, sizing the overcurrent protection for the generator feed to a fire pump requires careful consideration of the National Electrical Code requirements, the motor's characteristics, and the specific operating conditions. By understanding the rationale behind the code provisions and following best practices for installation, testing, and maintenance, it is possible to ensure the reliable operation of fire pump systems and protect lives and property in the event of a fire. Let's consider some practical examples to further illustrate the concepts discussed. Suppose you have a fire pump motor with a nameplate current of 100 amps. According to the National Electrical Code, the overcurrent protection for the generator feed to this motor can be sized up to 125% of the nameplate current, which would be 125 amps. In this case, you could use a 125 amp circuit breaker or fuses to protect the generator feed. However, it's essential to verify that the conductors supplying the motor are also adequately sized to carry this current. If the conductors are not rated for at least 125 amps, they must be upsized accordingly. Now let's consider another scenario where the fire pump motor controller is rated for continuous duty at 125% of the motor nameplate current. In this case, the overcurrent protection can be sized based on the controller's rating, rather than the motor nameplate current. This may allow for a higher overcurrent protection rating, providing additional margin for the motor to handle temporary overloads. However, it's still crucial to ensure that the conductors are adequately sized and that the overall system coordination is maintained. In addition to the overcurrent protection, it's also essential to consider the short-circuit protection for the generator feed. Short-circuit protection is designed to quickly interrupt high-magnitude fault currents that can occur due to insulation failures or other electrical problems. The short-circuit protection device must be capable of interrupting the available fault current at the generator terminals. This requires a thorough short-circuit study to determine the maximum fault current that the system can deliver. The short-circuit study should take into account the generator's impedance, the transformer impedance, and the impedance of the conductors and other equipment in the circuit. Once the available fault current is determined, a short-circuit protective device with an interrupting rating equal to or greater than the available fault current must be selected. This could be a circuit breaker with a high interrupting capacity or a set of fuses with an appropriate current limiting characteristic. It's important to note that the short-circuit protection device must be coordinated with the overcurrent protection device to ensure selective tripping. This means that the short-circuit protection device should only operate in response to high-magnitude fault currents, while the overcurrent protection device should operate in response to lower-level overloads. Proper coordination of protective devices is essential to prevent unnecessary tripping and maintain the reliability of the fire pump system. Another important consideration is the generator's ability to handle the motor starting current. Fire pump motors typically have high starting currents, which can cause voltage dips and potentially disrupt the operation of other equipment connected to the generator. To mitigate this issue, the generator must be sized to accommodate the motor starting current without excessive voltage drop. This may require oversizing the generator or using a soft starter to reduce the motor starting current. Soft starters gradually ramp up the voltage applied to the motor, reducing the inrush current and minimizing voltage dips. They can also provide additional protection against motor overload and undervoltage conditions. In addition to the electrical aspects, it's also important to consider the mechanical aspects of the fire pump system. This includes the pump itself, the piping, the valves, and the fire suppression system. The pump must be capable of delivering the required flow and pressure to the fire suppression system. The piping must be sized to minimize friction losses and maintain adequate water pressure. The valves must be properly selected and installed to ensure reliable operation. The fire suppression system must be designed to effectively extinguish fires in the protected area. Regular inspections and maintenance of the mechanical components are essential to ensure their proper operation and prevent failures. This includes checking the pump's performance, inspecting the piping for leaks or corrosion, and verifying the operation of the valves. Any deficiencies identified during inspection should be promptly addressed to maintain the integrity of the fire protection system. The integration of the electrical and mechanical components of the fire pump system requires careful coordination and communication between the electrical and mechanical engineers. This ensures that the system is designed and installed to meet the specific requirements of the application and to provide reliable fire protection. In summary, designing and installing a fire pump system requires a thorough understanding of the National Electrical Code, NFPA standards, and the specific requirements of the application. This includes proper sizing of the overcurrent protection, short-circuit protection, conductors, and generator, as well as careful consideration of the mechanical components and their integration with the electrical system. By following best practices and adhering to relevant codes and standards, it is possible to ensure the reliable operation of fire pump systems and protect lives and property in the event of a fire. To further enhance our understanding, let's consider the role of the authority having jurisdiction, or OJ, in the approval and inspection of fire pump installations. The AHJ is the entity responsible for enforcing the applicable codes and standards in a particular jurisdiction. This could be a local building department, a fire marshal's office, or another designated agency. The AHJ plays a crucial role in ensuring that fire pump systems are designed, installed, and maintained in accordance with the relevant codes and standards. The AHJ typically reviews the design plans and specifications for the fire pump system to ensure that they meet the applicable requirements. This includes verifying that the overcurrent protection, short-circuit protection, conductors, and generator are properly sized and that the system is designed to provide reliable fire protection. The AHJ also conducts inspections of the fire pump installation to ensure that it is installed in accordance with the approved plans and specifications. This includes verifying that the equipment is properly installed, that the wiring is correctly connected, and that the system is functioning as intended. The AHJ may also require periodic testing and maintenance of the fire pump system to ensure its continued reliability. This could include annual flow tests, pump performance tests, and inspections of the electrical and mechanical components. The AHJ has the authority to require modifications or corrections to the fire pump system if it is found to be non-compliant with the applicable codes and standards. This ensures that the system is brought into compliance and that it provides the required level of fire protection. Working closely with the AHJ throughout the design, installation, and maintenance phases of a fire pump system is essential for ensuring compliance and obtaining the necessary approvals. This includes providing the AHJ with all relevant documentation such as design plans, specifications, and test reports. It also includes responding promptly to any questions or concerns raised by the AHJ and making any necessary corrections or modifications to the system. In addition to the AHJ, other stakeholders may also be involved in the approval and inspection of fire pump systems. These could include insurance companies, building owners, and fire protection engineers. Each stakeholder may have their own specific requirements and expectations for the fire pump system. Coordinating with all stakeholders is essential for ensuring that the system meets their needs and that it is approved for use. This includes communicating clearly and effectively with all stakeholders, addressing any concerns or questions they may have, and incorporating their feedback into the design and installation of the system. In summary, the AHA plays a critical role in the approval and inspection of fire pump systems. Working closely with the AHA and coordinating with other stakeholders is essential for ensuring compliance, obtaining the necessary approvals, and providing reliable fire protection. Let's shift our focus to the importance of documentation and record keeping in fire pump systems. Accurate and comprehensive documentation is essential for ensuring the proper operation, maintenance, and troubleshooting of fire pump systems. This documentation should include all relevant information about the system, such as design plans, specifications, equipment manuals, test reports, and maintenance records. The design plan should show the layout of the fire pump system, including the location of the pump, the piping, the valves, and the fire suppression system. The plan should also include details about the electrical system, such as the wiring diagrams, the overcurrent protection settings, and the generator specifications. The specification should provide detailed information about the equipment used in the fire pump system, such as the pump's performance characteristics, the pipe material, the valve types, and the fire suppression system design parameters. The equipment manual should provide instructions for the proper operation, maintenance, and troubleshooting of the equipment. The test report should document the results of all tests performed on the fire pump system, such as flow tests, pump performance tests, and electrical system tests. The maintenance record should document all maintenance activities performed in the fire pump system, such as lubrication, filter changes, and equipment repairs. This documentation should be organized and readily accessible to authorized personnel. It should be stored in a safe and secure location where it can be easily retrieved when needed. Electronic documentation is often preferred as it can be easily searched and updated. Regular updates to the documentation are essential to ensure that it reflects the current state of the fire pump system. Any changes or modifications to the system should be documented immediately. This includes changes to the equipment, the wiring, the piping, or the fire suppression system. Proper documentation can greatly simplify the troubleshooting process when problems arise with the fire pump system. By reviewing the documentation, technicians can quickly identify potential causes of the problem and take appropriate corrective actions. Documentation can also be valuable during inspections and audits. Inspectors and auditors can use the documentation to verify that the fire pump system is installed and maintained in accordance with the applicable codes and standards. In addition to the technical documentation, it's also important to maintain records of all communications related to the fire pump system. This includes emails, phone calls, and meetings with the AHJ, other stakeholders, and service providers. These records can be valuable in resolving disputes and demonstrating compliance with regulatory requirements. Employee training records are also very important. Only authorized and qualified personnel should be allowed to make adjustments or repairs to the fire pump system. Training records can verify authorized personnel and help ensure compliance. In summary, documentation and record keeping are essential for ensuring the proper operation, maintenance, and troubleshooting of fire pump systems. Accurate and comprehensive documentation can simplify troubleshooting, facilitate inspections and audits, and demonstrate compliance with regulatory requirements. To conclude our discussion, let's consider the importance of ongoing training and education for personnel involved in the design, installation, and maintenance of fire pump systems. Fire pump technology is constantly evolving, and new codes and standards are regularly introduced. To ensure that fire pump systems are designed, installed, and maintained to the highest standards, it's essential that personnel receive ongoing training and education. This training should cover all aspects of fire pump systems, including electrical, mechanical, and hydraulic considerations. It should also cover the latest codes and standards such as the National Electrical Code and NFPA 20. Training can be delivered through a variety of methods such as classroom instruction, online courses, and on-the-job training. It's important to choose training programs that are accredited by recognized organizations and that are taught by qualified instructors. Certification programs are also available for fire pump technicians and engineers. These programs provide a way to demonstrate competence and knowledge in the field of fire pump systems. Continuing education is essential for maintaining certification and staying up to date with the latest developments. Employers should support their employees' participation in training and education programs. This can include providing financial assistance, time off for training, and opportunities for professional development. Investing in training and education is an investment in the safety and reliability of fire pump systems. Well-trained personnel are more likely to identify potential problems early, prevent failures, and respond effectively to emergencies. In addition to formal training programs, it's also important to encourage personnel to participate in industry events such as conferences, seminars, and workshops. These events provide opportunities to network with other professionals, learn about new technologies, and share best practices. Subscriptions to industry publications and online resources can also help personnel stay informed about the latest developments in fire pump technology. Furthermore, personnel should be encouraged to participate in professional organizations such as the National Fire Protection Association and the Society of Fire Protection Engineers. These organizations provide access to technical resources, networking opportunities, and professional development programs. By fostering a culture of learning and continuous improvement, organizations can ensure that their fire pump systems are designed, installed, and maintained to the highest standards. This will ultimately lead to safer and more reliable fire protection for buildings and their occupants. In summary, ongoing training and education are essential for personnel involved in the design, installation, and maintenance of fire pump systems. By investing in training and education, organizations can improve the safety and reliability of their fire pump systems and protect lives and property in the event of a fire.